Okay, been asked to do a little video on slopes, curves, etc. Shift, parallel shift. So if we go into my boiler, this is my boiler in my home. Heating curve. So actually this is the third take I've done of this video, and I've learned a few things myself from coming to explain it. We keep referring to curve, but on the boiler it says level and slope, and then we've got something called parallel shift. And what I've realized is if you have an amalgamation of slope and level, that would then be your curve. So that the curve is the actual line we end up with, and to make the curve we can adjust the slope and level, and the level is actually the parallel shift. So I think they are the same. Slope and curve are not the same because it could be an amalgamation of the two. But level and parallel shift are. So let's just explain a little bit about the weather comp here. So my boiler has accidentally arrived at close to 50-30 design. You can see at 0 I've got 50. The design temperature for this area is -1. So if I had 50 degrees at -1, that would be 50-30 design. If I go down to 1.3, you can see here that pretty much I would have 49-50 degrees at -1, and therefore somewhere between 1.3 and 1.4, and that there isn't an in-between, would be 50-30 design. So okay, if I raise this curve to give me a flow temperature of 60, and I've got delta T20 across my boiler, I've now got 60-40 design. If I go to 70, bear in mind these are going to be slightly out. This depends on your design outside temperature. I'm just accepting it as 0 for demonstration purposes. So this would be 70-50. And originally when I did the heat loss for my house, I used a Mears calculator. The Mears calculator worked out that I needed 15 kilowatts, and that was an amalgamation of my radiators plus a little bit for hot water. And I sized my radiators with the Mears calculator and selected from the catalogue based on delta T50, so that's mean water temperature to air temperature. Bearing in mind it was 11 degrees delta T on the design criteria back at that point. So I was selecting delta T50 on my catalogue, which would have given me a flow temperature of 75. So that would have been 75-65 design at that point. Obviously now we're running at delta T20 on our systems. So really if I was coming in here and the radiators had been correct from the Mears calculator, this is the slope that I would be setting, approximately, maybe a little bit higher, so 74. That would probably be about right for that. But anyway, due to the beauty of the Mears calculator overallowing for everything, what I've actually ended up with is a 1.4 heat curve and an exceptionally efficient system. So right, okay, so slope basically is going to adjust the curve to suit the type of system design you've got, and it works on the principle of setting we're really looking at the mean water temperature, but the boiler doesn't know the mean water temperature, it knows the flow temperature, so this is extrapolated across into flow temperatures. So we're setting this to give the correct flow temperature to achieve the correct mean water temperature to get the right heat output from the boiler, so as the radiator in the room matches the heat loss from the room to outside. So I hope that helps. Now the level, when you adjust temperature, so that's not in this panel, but if at the moment I'm set for 20 degrees room temperature, so it's showing that curve. But if I set the temperature, say I wanted to heat to 25, I can go up on my curve. That's now looking to give me a room temperature of 25 degrees, and I've adjusted the level manually here rather than on the temperature selection side of the boiler. I don't think you'd really want to do this with a standard curve, but what you might want to do is create standard slope, sorry, but you might want to create a sort of little bit of a hybrid curve. So for example, as humidity changes in the summertime, so as we're coming up to warmer weather, we don't need the same internal temperatures. We can drop the internal temperature slightly to get the same level of comfort. So what we could do is we could raise the slope and then reduce the level. And in effect, what this is doing is kind of steepening up our curve, so that as we approach this summertime period, we're going to drop off a little bit on our temperature. So, or you could see it the other way, that we're going to increase our temperature as we get to the colder period. So you could have a little play with that, trying to correct for those. So you could leave it set to one room temperature all the time. Now you wouldn't get the room temperature. This is very accurate for actual room temperature when it's set on the fixed slope. But this would be more about comfort. So you would actually get a situation where the temperature dropped below the set temperature based on humidity. And I do believe some boilers have got humidity sensors, and they can do the adjustments of flow temperatures based on the impact of humidity on the comfort level in the property. So I'm not quite sure how that correlates with temperature either, but it'd be very interesting if anyone's done that. I think Viessmann have the facility to adjust for humidity. I don't think Viessmann do have it, but it's never been a problem for me. My systems run very much on level within 1 degree centigrade across the rooms and for the set temperatures, and that's pretty much accurate enough. So right, let's go back to where I was. So I think that's explained everything. The relationship of weather comp, level, slope. So level was the parallel shift. The combination of the two, whether it's a combination or not, becomes the heating curve. So I think that's everything we need to say.